Okay, apply index laws to simplify algebraic expressions. Yay! Okay, so in red I've got your index laws and in purple the consequences of those index laws. So you can just rote memorize those if you want. I'm going to actually give you a feel for why these necessarily must be true, hopefully, so that you don't really remember them so much as you know them, like you understand them, and so you don't have to memorize things, which is always a good thing, in my book anyway. But you can just memorize if you want. So, let's go with this. Alright, x squared times x cubed. Alright, well, let's think about what that actually means. X squared just means x multiplied by itself, so I could replace that with that. In fact, actually, I'm going to change colours here. Let's go purple, because I do like the purple. X squared, so that's just x times x. Great. Okay, well, what's this? X cubed. Well, that's x times x times x. Great. And we're multiplying these two things together. Great, okay, well, hang on. This is just a string of 5 x's, so this is just the same as x to the 5. Well, that's interesting. 2 plus 3 is 5. Is that a fluke? Well, no, right? Because this 2 means you have 2 of them here. This 3 means you have 3 of them here. So whatever these two are, you're going to have that many of them, and together, you're going to have those two added together. So, we end up with this general rule. X to the power of a times x to the power of b equals x to the power of a plus b. Cool. Alright, well that's nice and easy. What about if we divide things? Alright, well, x to the 5 divided by x to the 3. Well, similar story. X to the 5, 1, 2, 3, 4, 5. X to the 3, 1, 2, 3. And now we're dividing them. Cool, okay, well, if I divide, I can just cross off things that are in common if they're on the top and the bottom, and it's all multiplies and divides. So I can go, alright, cross, 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 cross. I've got nothing left on the bottom, which I can think of as a 1 if I want. Divide by 1, that doesn't do anything, so I don't have to worry about that. What have I got left? Oh, I've got x twice, so x squared. Cool, well that's interesting. 5 minus 3 is 2. Is that a fluke? Well, for the exact reason as before, no, because that tells you how many on top, how many on the bottom, so how many are going to be left over is the difference of those two numbers. So, in general, x to the a divided by x to the b is always going to equal x to the power of a minus b. Cool. Next guy. Oh, hang on, we've got a power to a power. Power tower. Alright. Let's go x squared, so I've got x squared. And then this means do that multiplying itself 3 times. Oh, okay, so I've got one of them there, leave some space, and then I'll have another one, and another one. So x squared multiplied by itself 3 times. X squared multiplied by itself 3 times. Great. Oh, well, hang on. We know that this just means x by x. So I've got x by x, by x by x, by x by x. Well, there's 1, 2, 3, 4, 5, 6 of them. So that's going to be x to the 6. Cool. Ah, 2 times 3 is 6. Is that a fluke? Well, no, because you're going to have 2 in every set, and you're going to have 3 sets of them. Well, then I'm going to have 2 by 3. 6. That's always going to be the case. So, in general, x to the a, all to the power of b, is the same as x to the power of a times b. Beautiful. Well, we can fiddle around with this to get some more interesting results. Okay, I've got x to the 5 divided by x to the 4. Well, that'd give me 5 x's on top, 4 on the bottom. Well, I can cross off 4 sets on the top and bottom, so I'm just left with a single x. Cool, alright. Remember that this is implying x to the power of 1, which isn't surprising now since we've done these rules. 5 minus 4 gives me that 1. Okay, so I've got x to the 1, but we just said, well, that's the same as x. So x to the 1 is the same as x, unsurprisingly. It's an implied 1. Okay, well, what about x to the 4 divided by x to the 4? Well, I've got something divided by itself. Well, let's think about that for a second. If I have 10 divided by 10, what do I get? I get 1. If I have a million divided by a million, I get 1. So no matter what it is, it's always going to be 1. Cool, so I get x to the 0, because that's what this is. X to the 4 divided by x to the 4 is x to the 4 minus 4, so that's x to the 0. So x to the 0 is 1. There's one slight exception to this, which is a little bit irritating, so long as x does not equal 0. Now, for most of the time, you won't have to worry about that until you get a bit more technical and into things, but it's there for those of you that are a bit more technically inclined. Cool. Okay, x to the 4 divided by x to the 6. Well, okay, I'll have 4 on top, 6 on the bottom. Alright, I'll cross 4 of them off. Oh, hang on, but now I'm going to have nothing on top and then 2 on the bottom. Alright, well I can make that 2 on the bottom next square, but what should be going on the top here? Well, we were crossing things off, but we could have started with a 1 times x on top. So we can cross off all the x's, we're still left with that 1 on top. So we've got 1 over x to the power of 2. Well, we already know that power is minus when you divide, so unsurprisingly, this is equivalent to x to the minus 2. Because if we just go 4 minus 6, we get negative 2, x to the negative 2. This is the same as that though, because if we draw out our x's, we can cross them off and end up with a 1 on top. So it works out that this is the same as this. Fine. Cool. There is one slight thing that I would like to point out at this point though. If you have some number times x to the negative 8, then you get that number up here. Cool, that's the only thing. If you're wondering why, think of the b as a b over 1, and then you'll see that, oh, I get b times whatever's on top, which this would just be a 1 over x to the a, b times 1, b, 1 times x to the negative a, gives me, gives me that. Cool. Beautiful, that's that side done. Okay, so let's put some of this into practice in more annoying circumstances. Cool, got a whole bunch of stuff now. Oh good. Well, let's work our way through it. Highly recommend. Take care of your top row, simplify that down. Then take care of your bottom row, and only after both of them are as simplified as possible, then start merging them. Next top tip, go through in alphabetical order is usually a good idea. Okay, so I've got an x and another x over here. Great, okay, so I'm going to end up with x to the 7 because I'm timesing x to the 2 by x to the 5. Fine. Next letter. Oh, looks like that's y's. Y to the 3 and y. Well, remember, if there's no number, it's implying a 1. So x to the 3 times x to the 1. Add those together. Y to the 4. Remember? Go red. Z. Z to the 4. Z to the 2. Z to the 6. All over. X's again. Use the same colour. X to the 4 and x, which is an x to the 1. So that's x to the 5. Y's. Cool. Y to the 5, y to the negative 2. Oh, hang on, I've got a negative here. Does that matter? Well, no, I'm multiplying these things, so I'm just going to add them together. 5 plus negative 2 is just 3. So that's all well and good. What colour did I do? Red. Cool. Z to the 6, Z to the 0. Oh, does the 0 matter? Well, I'm just going to add them. 6 and 0 is still 6, so that's fine. Z to the 6. Great. Cool. Can I do anything else with the top? No, they're all different. Can I do anything with the bottom? No, they're all different. Okay, now I can do vertical. Start cancelling things. X to the 7 over x to the 5. If it's over it, that means divide, so I'm minusing the powers. Cool, I've got 7 minus 5, so I get x to the 2. Great. Well, what about y's? Y to the 4, y to the 3, so I've only got 1. I could write the 1, but it's unnecessary. Z to the 6 over z to the 6. Hang on, that's z to the 0. So you could write z to the 0 for a moment until you realise, hang on, z to the 0, anything to the 0 is 1. So this is just a times by 1. So it ends up being irrelevant, so we don't actually need to put that in. So we just end up with, we can put that there if you desperately want, equals, go. Alright, x squared and y, don't need to mention the z. So that's that. So you can have that as a working line if you like, but your end result should simplify nicely. Beautiful, so we took something reasonably complicated and brought it right down to something much neater and easier to work with. That's why we learn this stuff, to make our harder things a lot easier to deal with. Okay, now we've got this chunky boy. Alright. Well, as always, start top, then do bottom as best you can, and only after that start merging the two. Cool, alright, well, I've got a whole bunch of numbers in here as well. So this time I will use, what colour did I not use last time? Orange? Orange. Cool, I've got 2's here. Now this 2 is going to cop this. Oh, that's interesting. Maybe I should do this in another step then. Okay, what I'm going to do is expand these power brackets first. So we get 2, x to the 3, multiplied by. Everything in this cops that 3. So 2 to the power of 3. What's 2 to the power of 3? 2 times 2 times 2, not 6. 2 times 2 is 4, times 2 again is 8. We get 8. X to the 3 is x to the 3. Times y, 3 to the power of 2. Well, that just squares it, so 3 times 3, 9. Y squared, done. Over. This thing, nothing happened yet. I'm worried about this. Okay, 5 squared, 5 times 5, 25. X to the 2 to another 2. Oh, okay, we need our rules. We go back to this, 2, 2, multiply them together, x to the 4. Same thing, 3, 2, back to the rule, 3, 2, 3 times 2 is 6. Negative 2 to the power of 4. Oh, okay, well, this might get a little bit fiddly, so we think about it. A negative times a negative times a negative times a negative. A negative times a negative is a positive, times another negative goes back to negative, times the fourth negative becomes positive again. So this is going to be positive. I could write in a positive here if I wanted to, but again, it's unnecessary. The shortcut for that is whenever you have an odd number of negatives, you're always going to be negative. Whenever you've got an even number, you're always going to be positive. Cool. 2 to the power of 4, it's not 8. 2 times 2 is 4, times 2 again, 8, times 2 again, 16. Cool. Okie dokie. Now, this is looking like we've got a lot of big numbers to deal with. Would really rather not have to deal with that if we can avoid it. Okay? Well, what are we going to do about it? I'm going to get rid of this plus because it's getting in the way for my eyes. Okay, well, is there anything that we can see that cancels out? Well, yeah, there is. If we go 2 times 8, that would give me this 16. I've got a 16 on top, 16 on the bottom. Kill it. Beautiful. Okay. Is there anything else? Well, 4 only has 2s as factors, 25 only has 5s, 9 only has 3s. They're all got different factors, nothing's going to happen. Okay, so maybe now we can start to join things up. Now, if you wanted to, you could join them up without crossing anything off. That's totally fine, just your numbers are going to get ridiculously large really quickly, and that increases your odds of making a dum-dum. So let's try to avoid that. Cool. Top line. Okay, all my perfect numbers. Well, that's gone, that's gone. I've only got this guy left, so I've got a 9. Okie dokie. And what colour do I have? Purple? Yep. Cool. Purple for x's. Cool. X to the 3, x to the 3. That gives me x to the 6. Next, y's. There's only one of them. Y. Oh, sorry, that should be green. Whoopsie. Speak of dum-dum. Cool. Okay. Great, that's the top all done. Bottom one. Pure number, pure number, pure number. Oh, that's gone, sorry. 4 by 25, that's 100. And I should have drawn that over. D. Purple for x's. We've got x to the 5, x to the 4. That's x to the 9. Green. Just y to the 6, nothing to match him with. Okay, great. Now typically I would suggest keep working down the page. I'm going to run out of space here, so I would highly recommend you don't work across the page, but I don't have a whole workbook to work with, so here we go. Okay, pure numbers first. 9 and 100, do they have anything in common? No, they don't. This divides by 3 and that's it. This does not divide by 3, so I'm going to keep my 9 on top and keep my 100 on the bottom. Cool. X to the 6 over x to the 9. I've got 3 extras on the bottom, so x to the 3. Y to the 2, y to the 6. Well, I've got 4 more on the bottom. Done. Cool. Give it a last glance, make sure nothing else cancels out. No, we're done. Beautiful. So that's the gist of that. Now, this next bit is more of an extension for those of you that are keen for it. We'll run through the generation of it. Okay. Imagine that I've got x to the half times x to the half. What does a half power mean? We don't know yet. Well, even so, I can say, well, this and this, that's got to be the same as x to the half plus a half, which is x to the 1. Well, that's just x. Well, if I think about this as some number and this as just that same number, so I'm saying some number multiplied by some number equals another number. Well, that's just saying a squared equals x. Or in other words, that if a is the square root of x, because a times itself equals x. So it looks like a power of a half just means square root. Well, that's interesting, but what if it's a different fraction? Maybe this doesn't always work out. Okay, what about if we do this? So I've got x to the 2/3 multiplied by itself 3 times. Well, I can add up those fractions and see that that's x squared. Alright, so I've got some number multiplied by some number multiplied by some number equals this other number. Well, that's the same as saying, if I call these a's, that means a to the power of 3 equals some number squared. Now if I think of this as some other number, alright, so that's y, that would mean that a is the cubic root of whatever this y number was, but y is x squared. So we get that. And so, these 2's and 3's clearly aren't special numbers because they're ending up in these nice spots. So we can generalise this to say x to a fractional power is the bth root of x to the power of whatever the numerator is. Cool. Alright, well let's try this out. We've got all of this to the power of a half, so everything cops that power. 25 to the power of a half. Remember, we just figured out that a power of a half is the same as a square root. So we've got square root of 25 multiplied by, no, I won't do that. Cool, okay. X to the 6 times this, well, we can just use our old rules back here to do this. 6 times a half is x to the 3. Cool. Square root of 25, hopefully we know, is 5. So we get 5 times x to the 3. Cool. Oh, hang on, this is looking a bit chunky boy. Well, alright, we've got a couple of options here. We can go, 64 squared, and then take the cube root. And then this times this, 9 times 2/3, so we can do this a slow way if you want. So I've just done 9, which is the same as 9 on 1, times 2/3, so I get 18 on 3. Great, well, this can definitely simplify. We get x to the 6. What about this? 64 squared and then try and find the cubic root of that? That's sounding a little bit dangerous. But what we can do instead is say, hang on, this thing counts as a power. So what I can actually do is move this 2, if I want, to the outside, and that's perfectly valid. Okay, well, does that make it easier? What's the cubic root of 64? So what number multiplies by itself a total of 3 times to give 64? And with a little bit of fiddling, you might figure out, oh, that's 4. But the whole thing is still squared. Cool. So I end up with 4 squared 16, x to the power of 6. That's that. Cool. So this is definitely for not the faint of heart, because you'll get a whole lot of roots and things that'll go weird. But it's definitely good fun if you can get it down. Cool. So that's our quick recap and hopefully not just an introduction to index laws. If you've got any troubles or anything, email away. Otherwise, good luck.